So over here, AB is parallel to CD, and what we are trying to prove is that angle IEB is equal to angle EFD. So our strategy is going to be that we'll try to prove by contradiction. So what we're going to try to, so what we'll assume is that, right here, I'm going to assume that, yep, assume that angle IEB is not equal to angle EFD. So without loss of generality, I'll explain what this means afterwards. G. We'll say that angle EFD is greater than angle EFD is greater than angle IEB. Alright, so now that we have proved this, we'll try to construct a ray at angle EFD such that the angle formed by the ray and the line EF will be equal to angle IEB. So try to get that picture. Yep. So in this picture I drew the ray, so I'll put it somewhere over here. Goddamn. Okay, so over here I drew the ray FG. Not really a ray, it's a line segment FG, such that it will such that angle EFG is equal to angle IEB. So I'll write it down here. Not write it down, I'll just line segment such that angle EFG, I'll just write it down, EF G is equal to angle IEB. Yeah, so now that we have made such a line segment, we'll try to find few properties of the same line segment. Alright. More like we'll try to find out what happens to it when we actually take this line segment FG and we actually extend it. We'll see what its relation will be with AB. So the first case was that FG will be parallel to AB. So if FG has to be parallel with AB, it also needs to be parallel to CD. But it can't be parallel to CD because CD and FG share one point, which is F. So the only possibility in which FG will be parallel to AB is that if FG coincides with CD. Because it coincides with CD and CD is parallel to AB, we can say that FG will be parallel to AB. So FG will only be parallel to AB if FG So in this first case, I'll just write it down. FG coincides with CD. Yeah, so this is, if FG is going to be parallel to AB, FG has to coincide with CD. So if FG coincides with CD, uh, we have constructed FG such that angle IEB equals to angle EFG, which we have written over. I'll just copy it down. As we know that angle EFG equals to angle IEB, we can say that, yeah, so as we know angle EFG equals to angle IEB, we can say that angle EFD, this has to equal to angle EFD. I'll explain why. Why does angle IEB has to equal to angle EFD? Because of this. Because FG coincides with CD, they will form the same angle. So yeah. So now we'll have to deal with case 2. Case 2. FG is not parallel to AB. And this is actually the case which this is actually the case which my image here represents. So if we say FG is not parallel to AB, then at some point when we extend FG, FG must intersect AB at some point. So I extended it, and for some point K, FG intersects the extension of FG intersects AB. So move this a bit. I'll just get things a bit more clear. Yeah, so in our case 2, this is what we'll be doing is that we'll have to have a look at triangle EFK. So in a triangle EFK, angle IEK is an exterior angle. Is an exterior angle. So as angle IEK is an exterior angle, angle IEK must be greater than any of the either two angles which are not related to the exterior angle. So angle IEK must be greater than angle EFK. So but by construction, angle EFK is actually equal to angle IEK. Actually equals to angle EFK. Sorry. Okay. I'll just write a but here. This contradicts our assumption that so all of this which we have done is due to the assumption which we used at first, that angle IEB does not equal to angle EFD. But case 2 and case 1 actually prove that this assumption is wrong. So because of this, so I'll write it down. Our assumption is wrong. So and put this a bit over here. So angle IEK must equal to IEK. God damn it. IEK must equal to. I used B before, right? I'll use B, but same thing. Angle IEB must equal to angle EFD.